Good morning. We will start session 5 on chapter number system. We completed the exercise in our previous session, but there are some additional sums on this chapter which are actually very important from examination point of view. So few sums will be solved here in the class, and the remaining sums you can practice, remaining similar type of sums you can practice which are given in your mathematics assignment book. So that is question bank which is given already to you. So let's start with these sums. I'll be only solving one type of a particular sum or an example, what you can say, which you can do similar in the given question bank. First one, if x is equal to 3 plus 2 root 2, find the value of, if x is equal to 3 plus 2 root 2, find the value of x cube plus 1 by x cube. Now, we have taken this type of a sum. Sometimes it is also asked, find the value of x square plus 1 by x, or find the value of x square plus 1 by x square, or find the value of x plus 1 by x, right? So, one pattern of the sums I will be solving it in the class here. Whenever you have a given value of x is given and you have to find something in the form of a cube, something in the form of a square root or a square, or only the term itself. First of all, look, we have x here. Yes, we have also x here. We have another term as 1 by x cube. That means before finding 1 by x cube, I should know what is 1 upon x, right? So with the given value, we find 1 upon x. More or less, these sums are again a type of rationalizing kind of a sum. Solution: x is equal to 3 plus 2 root 2. This implies 1 by x is equal to what? 1 upon 3 plus 2 root 2. Okay. So now it is how this sum is in the form such that it is an irrational root is there here. That means denominator is not in the correct rational number. We need to rationalize it to bring it into a proper form. RF of 3 plus 2 root 2 is 3 minus 2 root 2. As I have told you, writing RF is very important. So how do we write now? 1 upon 3 plus 2 root 2. So this is what? 1 by x is equal to into 3 minus 2 root 2 divided by 3 minus 2 root 2. Do the further process. 3 minus 2 root 2 divided by a plus b, a minus b, a square minus b square. Right? Next step would be numerator as it is 3 minus 2 root 2, denominator 9 minus 2 square is 4, root 2 square is 2, so 4 2s is 8. Therefore, 1 upon x is equal to 3 minus 2 root 2 divided by 1, that is nothing but 3 minus 2 root 2. Okay, keep this as it is. Next step. Though they have asked us x cube plus 1 by x cube, first let us find in the form of x plus 1 by x. Now, how do I know that? Or how do we know that? We have to find like that. Why not like this? That comes by practice. If you solve such many numericals, you will get an idea what should be your next step. So, not let. We will just write here x plus 1 by x is equal to. What is your x? X is in the form of 3 plus 2 root 2. Plus, what is 1 by x which you have got here? If you want, just put this in a box. Answer is 3 minus 2 root 2. 2 root 2 and 2 root 2. One is plus, one is minus will get cancelled. 3 plus 3 is 6. So, x plus 1 by x is equal to 6. This is not the answer yet. We want it in the form of x cube plus 1 by x cube. How do we get this sum in the form of x cube plus 1 by x cube? Cubing on both sides. Cubing on both sides. If in case square was asked, squaring on both sides could have been done. So x plus 1 by x whole cube is equal to 6 cube. Identity a plus b whole cube, a cube plus b cube plus 3ab of a plus b. So I will write here x cube plus 1 by x cube plus 3x into 1 by x dot represents into of x plus 1 by x is equal to 6 cube is 216. So keeping few terms as it is, x cube plus 1 by x cube plus x and x will get cancelled. 3 into what is x plus 1 by x? 6 is equal to 216. X cube plus 1 by x cube is equal to 216. 6 3s is 18. That is what you have got. X cube plus 1 by x cube is equal to 216 minus 18. When you subtract this, you get 198. This is the answer. This is how you solve the sum. Okay, it is very simple, but you should know the trick how to actually start with the given sum. So now you have an idea if such type of numericals are given in how to solve about it. Similar sums are given in the assignment. You can practice it for more different types of sums here. Okay, let's go over the next type of a sum. You can copy this down. The next sum, if 2 upon root 3 plus 5 plus 5 upon root 3 minus root 5 is equal to a root 3 plus b root 5, find the value of a and b. So when you have such type of a sum, simple, whenever you look at such type of a numbers, it is understood that we have to rationalize them individually and then add them. That is the first step what we do. But look at the denominator here. 3 plus root 5, 3 minus root 5. It is of the form a plus b, a minus b. It is very easy for us to take LCM and solve it, right? In case if the sum was like this, then what we would do, I would rationalize this separately, I would rationalize this side separately and then add them, okay? But here, since it is in the form, usually the sums will not be in this form, but observe the denominator. If it is in the form of a plus b, a minus b, you can always use that method. But here let me not create confusion, we'll follow rationalizing factor only. Right. RF of root 3 plus root 5 is root 3 minus root 5 and RF of root 3 minus root 5 is root 3 plus root 5. If you want children, you can take LCM and try. Okay. This is done. Since it is a binomial kind of a thing, one term, we have to do it simultaneously, which I suggest. Some of you all, what they will do in this sum, they will solve this, then you add it sometimes you miss some terms. Whenever such things are given, I want you all to do that simultaneously and do it. It is very simple to do. Equal to 2 upon root 3 plus root 5 into RF is root 3 minus root 5 divided by root 3 minus root 5 plus sign which is here. 5 upon root 3 minus root 5 into root 3 plus root 5 divided by root 3 plus root 5. Okay. 2 of root 3 minus root 5 divided by root 3 square minus root 5 square plus 5 of root 3 plus root 5 divided by root 3 whole square minus root 5 whole square. Let's multiply this. Coefficient only we can do. So it is 2 root 3 minus 2 root 5 divided by, it is 3 minus 5. 3 minus 5, shall I write minus 2 directly? Okay. Plus, next is 5 root 3 plus 5 root 5 divided by 3 minus 5 is minus 2. Okay. Next step. Since LCM is minus 2, keep minus 2 as it is. 2 root 3 minus 2 root 5 plus 5 root 3 plus 5 root 5. Okay. Group the like terms. Root 3 is like term. Root 5 and root 5 is a like term. So 2 root 3 and 5 root 3. I can write this as 2 plus 5 root 3 plus next minus 2 plus 5 of root 5 divided by minus 2 as it is. Next step, I'll go with here. 5 plus 2, 7. 7 root 3 upon, okay, after whole will take. 7 root 3 plus 5 minus 2 is 3. 3 root 5 divided by minus 2. Since we can take now individual denominator, this is equal to minus 7 by 2 root 3 minus 3 by 2 root 5 is equal to a root 3 plus b root 5. This is the final answer, which is of the form a root 3 and b root 5 we will write. Again, it's in the form of root 3 and root 5 only. What is the coefficient of root 3 here? A. What is the coefficient of root 5? B. What is the coefficient of root 3 here? Minus 7 by 2. Coefficient of root 5? Minus 3 by 2. Therefore, what is your A value? Minus 7 by 2. What is your B value? Minus 3 by 2. This is how you find these sums, right? Simple. Your thing is to forget about the RHS what is given. You know how to rationalize it. I have done by rationalization only because usually you get the sum in rationalizing form. Only this sum is in the form of a plus b, a minus b. Try with LCM. You have to get the same answer. Go on doing the process. You arrive at the final answer. Divided by some number will be there. Take individual denominator and finish it. Then it has to be, teacher, what if you get then not in root 3 and root 5, you get something else, root 6 and root 7 you get. That means you have done the question wrong. You have done the solution wrong. You have to get the final answer in the form of root 3 and root 5 only, because the type of question given, answer also is in that form. If you have gone wrong in the root itself, that means you have messed up with the given question, right? So once you get this, equalize the coefficients where you get the answer. So this is one type of sum which is very important. The next sum, prove that 2 upon root 5 plus root 3, 1 upon root 2 plus root 3 minus 3 upon root 5 plus root 2 is equal to 0. The second type of question can be, find the value of 2 upon root 5 plus root 3 plus 1 upon root 2 plus root 3 minus 3 upon root 5 plus root 2. Now here they have given directly 0, that means you know the answer should be 0. Otherwise they will give you find, simplify, anything like that. What comes to your mind when you look at this type of sum? Always first and foremost is to rationalize the denominators individually for the given numbers, right? Let's do that. Let's write the rationalizing factor. RF of root 5 plus root 3 is root 5 minus root 3. Root 2 plus root 3 is root 2 minus root 3, and root 5 plus root 2 is root 5 minus root 2. RF I have written. I am going to solve this sum simultaneously. I will not solve this first and this later. Again, it's up to you children, whichever you feel convenient. Bring the answer 0 at the last by appropriate steps. 2 upon LHS I will write first. LHS. 2 upon root 5 plus root 3 into root 5 minus root 3 divided by root 5 minus root 3 plus 1 upon root 2 plus root 3 minus into root 2 minus root 3 divided by root 2 minus root 3 minus 3 upon root 5 plus root 2 into root 5 minus root 2 divided by root 5 minus root 2. Okay? And minus sign is there. Be very careful because when binomial comes, signs will change. So when you multiply this, what do you get? 2 root 5, directly I am doing this, minus 2 root 3 divided by root 5 square minus root 3 square. Do not try to skip the steps. At least you show in one step that a square minus b square plus 2 root 5 minus 2 root 3. Here into 1 it is. So root 2 minus root 3 divided by root 2 square minus root 3 whole square minus, if you want you can take bracket here for the whole thing. So this is 3 root 5 minus 3 root 2 divided by root 5 square minus root 2 square. Okay. So when we simplify this, what do you get here? 2 root 5 minus 2 root 3. Here I can skip one step and write directly. It is square and root will get cancelled. 5 minus 3 is 2 plus root 2 minus root 3 divided by 2 minus 3 is minus 1. Here keep minus as it is if you want now. 3 root 5 minus 3 root 2 divided by 5 minus 2 is 3. Now, what is it here? We have different denominators. That means we need to take an LCM. What is the LCM here? LCM here is, or first what we can do is we can also change the sign and make this as 1. Okay, LCM is 6. Before you take, shall we do that? Shall I rewrite this in the form of, since minus is in denominator, we'll take minus here. 2 root 5 minus 2 root 3 divided by 2 minus I have taken, so this is going to be root 2 minus root 3 as it is. I have taken this minus here, bracket I have taken, divided by 1 minus 3 root 5 minus 3 root 2 divided by 3. LCM is 6 children. So if LCM is 6, I have to multiply this by 3. I have to multiply this by 6. I have to multiply this by 2. Let's do that. 3 2s are 6 root 5. 3 2s are 6 root 3 minus, we'll open the bracket, 6 root 2 minus minus plus 6 root 3 minus 3 2s are 6 root 5 minus minus plus 6 root 2. Check. 6 root 5 plus 6 root 5 minus cancel. 6 root 3 minus 6 root 3 plus cancel. 6 root 2 plus 6 root 2 minus plus cancel. So what did you get? 0 upon 6, that is equal to 0, that is RHS. You got the answer right? So this is how we solve the sum. Now see here children, while simplification there are so many different methods you can approach. This is straight away, usually what we do is I have written, right? But let me just take you to few more steps here. What else adjustments could have been done? Look at this. Can I take 2 common here? If I take 2 common, can I cancel that 2 and common 2? What will remain? Root 5 minus root 3. Here it is minus we have taken. Here means denominator is 1. Denominator is also 1 here. What about here? Can I take 3 common? Yes. What will I get? Root 5 minus root 2. Denominator is 1. That means I can easily I will get off this step without multiplying like this. I'll just show you for one. If I take 2 common here, it is root 5 minus root 3 divided by 2. 2 and 2 I can cancel. Please do not cancel this 2 and this 2 anywhere. Minus sign is there. Got that there? We got root 5 minus root 3. Similarly, this would be minus root 2 plus root 3. So this would be 3 common here. If I take 3 and 3 will get cancelled. Minus root 5 plus root 2. Cancel everything, you will get answer 0. There are so many different things. I have done old traditional method. Do as it is, then take off LCM and do anything. It's up to you. So now you have an idea of how to solve these type of sums. You can try this. Do not stick to usually what we do it on the board. You can also try by your own things by changing it but correctly. Okay. You can also try it like this by taking common and do it. So let's start with the next one. So I am only doing one pattern of these sums so that the remaining sums you can solve it by yourself. Next sum I will be solving on exponent based, where in exercise we have very simple sums. Okay. That was third one, right? Fourth one. Prove that 2 raised to 30 plus 2 raised to 29 plus 2 raised to 28 divided by 2 raised to 31 plus 2 raised to 30 minus 2 raised to 29 is equal to 7 upon 10. Now, will you sit and multiply 2 raised to 30 how many times? 2 raised to 29 and then simplify? No, it's absolutely not possible to multiply and waste your time. Rather, the trick is here, take common. Just look at the numerator. What is the maximum number of terms 2 raised to you can take common? 2 occurs here 30 times, 29 times, 28 times. Can I take 2 raised to 28 common? So what will remain according to exponential rule? 2 raised to 2 will remain, correct? 28 plus 2 is 30. 2 raised to 1 will remain. 28 plus 1 is 29. Last. Plus what will remain here? 2 raised to 0 I can write, or it is nothing but 1 anyhow. 2 raised to 28 into 1 is 2 raised to 28. Very clear? Denominator, you see, what maximum you can take common? You can take 2 raised to 29 common. If 2 raised to 29 is common, 29 plus what will give you? 2 raised to 2. 30 it is, plus 2 raised to 1. 29 raised to 29 minus 1. Please do not cancel numerator and denominator. Why you cannot cancel? It is minus 1, it is plus 1. You can't even cancel 2 raised to 2, 2 raised to 2, 2 raised to 1, 2 raised to 1. No, because you have addition or plus sign in between. We cannot cancel when we have addition or plus sign. You can only cancel when throughout it is a multiplication. But here, 2 raised to 28 times and 2 raised to 29 times, if I cancel, what will remain? 2 raised to 1 will remain. I'll keep that as it is. 2 square is 4. 2 raised to 1 is 2. Plus 1 as it is. This 22 raised to 1 because 28 times 29 times, or show exponential rule. 2 raised to 29 minus 28. 2 square 4. 2 raised to 2 minus 1. 4, 5, 6, 7. 2 raised to 4, 5, 6. 6 minus 1, 5. So answer is 7 by 10. You have several sums like this where anything number can be given, but you need to take common. And whatever numbers are given, that will be the same base. They will not give a combination of base. Say 2 raised to, 5 raised to, or 6 raised to. The base has to be same in the given question. So we'll move to the next one. Now, if you remember, I had told a type of a sum where we can multiply the given surd, that is root 3, root 4, root 5 or something. Sorry, root 4 is 2 anyhow. But root 3 and root 5 we can multiply only if they have same order. That is, if I want to multiply root 2 into root 3, I will directly say it is root 6. Sorry, root 6, root 12 I can say. Right? But if I have cube root of 2 into square square root of 6. I can't multiply directly and say it is cube root of 12. I cannot be multiplying that. There is a rule for multiplying, that is we equalize the orders of the given numbers, right? How do we do that? So here it is given, it's simple question. Write in ascending order. Write in ascending order. Okay, the same question can be asked as find the product of. Now here it is ascending order I am giving. It can be also asked as product. Usually sometimes these product sums are asked in MCQs, wherein you feel that it is simple multiplying, but when orders are different you cannot multiply them. The question is 4th root 3. Now children, to write this first of all. Now see here 4. This 4 should come inside the root 3. Please don't write like this. It is wrong. This is coefficient and this is order. Completely first write 4 if you want. In that the root should come. There should be clear thing of writing 4 root 3. If you write it like this outside the root, that becomes a coefficient. So 4 root 3, comma 3 root 2, comma and cube root of 4. So we have 3 orders. So one is 4 root 3, one is 3 root 2 and another is 3 root 4. So let us first find the order, or we have to first equalize the given orders. Solution. Take LCM of orders, or you can say LCM of the given orders are. LCM of the orders are what they are? 4, 3 and 4. LCM is 12. Okay. Then index form of the given numbers are written as, we all know how to write index form of the given number, right? So first number can be written as 3 raised to 1 by 4, comma 2 raised to 1 by 3, comma 4 raised to 1 by 3. That is how you write the index form of the given numbers. Now equalize the, we have taken the order, equalize the exponents of the given numbers. Now children, if it is asked for 1 mark, you will not follow these steps. These steps are only for your understanding. Equalize the exponents of the given numbers. How we have to equalize? LCM is what? 12. So 3 raised to 1 by 4. 4 into what will give you 12? 4 into 3 will give you 12. So into 3, comma 2 raised to 1 by 3 into 4 into 4. Next 4 raised to 1 by 3 into 4 into 4. I can write this number as 3 raised to, don't cancel 3 and 3 again. So I can write this number as 3 raised to 3 by 12, comma 2 raised to 4 by 12, comma 4 raised to 4 by 12. Okay. Now whatever is in the denominator, that is the order. This implies I can write this sum as 12th root of 3 cube, comma 12th root of 2 raised to 4, comma 12th root of 4 raised to 4. Now let us simplify this further. 12th root of 3 cube, 3 3s are 9, 9 3s are 27, comma 12th root of 2 raised to 4, 2 2s are 4, 4 2s are 8, 8 2s are 16, comma 12th root of 4 raised to 4, 4 4s are 16, 16 4s are 64, 64 4s are, you get 50. I'll write it here. This implies I will write 12th root of 16 is less than 12th root of 27 is less than 12th root of 256. What exactly is 12th root of 16? 12th root of 16 is the second one, that is cube root of 2 is less than, second is what? 27. So first one, fourth root of 3 is less than the last one, which is cube root of 4. This is how you solve the sum, and this is by, in case if they ask us to find the product, we need to multiply them and keep the answer, right? Or this is the ascending order. So in the last two more sums we have, find the value of p. You had such type of sums in your 8th standard. 5 raised to p minus 3 and 3 raised to p 2p minus 8 is equal to 225. But there you had the same base. We have different combination of base here. Be very careful. We cannot apply the first law of exponent here because this base is 5 and this base is 3. So let us solve it individually if you want. 5 raised to p minus 3 into, dot is always represented in exponential form. Instead of into, dot is also used. Into 3 raised to 2p minus 8. Now 225 is actually what? 15 square, right? So it can also be written, okay, 15 square we'll first write. It is 15 square. Can we split 15? Yes. How? 3 5s are. 5 raised to p minus 3 into 3 raised to 2p minus 8 is equal to 15 can be written as 5 into 3 raised to 2. Always remember, when they give you a term here of two different base and equal to a particular number, that number when you split will always be in these two combination form. You can ask now, what if it is a not combination? Not possible. They will not give you such numbers wherein it is not in the same combination form. Any number given here should be in the product of this combination form only. Okay. Next. 5 raised to p minus 3 into 3 raised to 2p minus 8 is equal to exponential rule 5 square into 3 square. Now start equalizing. When bases are same, powers are also same. Wherever 5 is there, we will equalize 5. Wherever 3 is there, we will equalize 3. So how can we write this here? 5 raised to p minus 3 is equal to 5 raised to 2 and 3 raised to 2p minus 8 is equal to 3 raised to 2. So here p minus 3 is equal to 2, p is equal to 2 plus 3, p is equal to 5. You want to try here, you will get same answer. Or 2p minus 8 is equal to 2. 2p is equal to 2 plus 8. 2p is equal to 10. P is equal to 10 by 2. P is equal to 5. P value will be same for both. That means you can either simplify with this or simplify with this. You will get the same answer. So we have last one question again, which is based on exponents only. We'll finish that and then we complete with number system chapter. Similar sums, I want you all to practice it given in your question bank assignment book. The next chapter will be starting on triangles. 7th one, x raised to a minus b of a plus b, x raised to b minus c of b plus c, x raised to c minus a of c plus a is equal to 1. Okay, sorry, it is prove that. Prove that x raised to a minus b of a plus b into x raised to b minus c of b plus c into x raised to c minus a of c plus a is equal to 1. We will start with LHS. Now, according to the exponential law, we can multiply the powers. So, this is going to be x raised to a minus b into a plus b, x raised to b minus c into b plus c, and x raised to c minus a into c plus a. A minus b, a plus b, x raised to a square minus b square, x raised to b square minus c square, x raised to c square minus a square. First exponential law, we can add them. X raised to n into x raised to m is equal to x raised to m plus n. X raised to a square minus b square plus b square minus c square plus c square minus a square plus a square minus a square plus b square minus b square plus minus c square plus c square. X raised to 0. Any number raised to 0, answer is 1, and that is RHS. There we complete number system chapter, including some additional problems. So, any doubt in this today's class or in the whole chapter, you can call on the same day of the video set. Our next session will be on the new chapter, triangles.